Good morning, students. Our today's topic in the subject of chemistry O levels is redox reaction. So this is a conceptual topic. So you have to concentrate because a lot of concepts and ideas will be involved in this topic. This is a technical topic. You should be very careful now. So we are going to start. Concentrate yourself. A redox reaction is a reaction where both oxidation and reduction processes occurs simultaneously. So it is a process in which reduction and oxidation occurs simultaneously, means at the same time. That kind of reaction is called redox reaction. So first we are going to read what is meant by oxidation reactions. So oxidation reactions involves a gain in oxygen. Okay. At the same time, I'm giving you ideas of the reduction processes. So oxidation and reduction are reverse of each other. So if in oxidation reaction, a gain in oxygen, then in reduction reaction, a loss of oxygen. Okay, a loss of hydrogen is oxidation reaction, whereas a gain in hydrogen is called reduction reaction. A loss of electrons is called oxidation reaction, whereas a gain in electrons is called reduction reaction. An increase in oxidation numbers is called oxidation reaction, whereas a decrease in the oxidation number is called reduction reaction. So it means if you learn the ideas of reduction reaction or oxidation reaction, then the reverse of these ideas will be of the other reaction. So oxidation reaction and reduction reactions are reverse of each other. So now there are 4 points. First, learn them. Number one, oxidation reaction is a gain in oxygen, a loss of hydrogen, a loss of electrons, or a increase in oxidation number. So now, if you only look at this category, that is oxidation reaction, so there is increase in two ideas and decrease in two ideas. Increase in oxygen or increase in oxidation number, and loss in hydrogen or loss of electrons. So these are actually 4 points which are actually involved in oxidation as well as reduction reaction. So these are actually reverse of each other. So first, learn and understand these ideas, because without these ideas you will not be able to handle the questions of these kind of questions. Here are two more terms. An oxidizing agent is a substance that is easily reduced. So another very important point is here. If one agent is oxidizing agent, that will be easily reduced. So oxidizing agent is reduced and reducing agent is oxidized. So these are reverse of each other. So again read, an oxidizing agent is a substance that is easily reduced. A reducing agent is a substance that is easily oxidized. So these are very two important terms. Okay, here is an example. Now we have learned 4 ideas involving oxidation reaction and reduction reaction. These are increase in oxygen, loss of hydrogen, loss of electrons, or a gain in oxidation number is called oxidation reaction. So now we are going to read 4 examples involving these ideas one by one. So number 1 is a loss of oxygen or a gain in oxygen. This is the first point. So look now, here is an example. H2 plus PbO forms H2O plus Pb. In this reaction, if you can see, H2 is gaining oxygen and PbO is losing oxygen. So here, if you can see, this is gain in oxygen and this is loss in oxygen. So look now, if gain in oxygen is there, this will be called oxidation reaction. If loss of oxygen is there, that is a reduction reaction. So H2 reduces PbO to Pb. That's why H2 is called a reducing agent. So H2 is reducing PbO to Pb. That's why H2 is called reducing agent. At the same time, PbO oxidizes H2 to H2O. So look now, PbO oxidizes H2 to H2O. That's why this is called oxidizing agent. So this is the first example. Now we are going to read an example involving gain in hydrogen and loss in hydrogen. So look now, H2S, this is loss of hydrogen. If you can see, H2S has lost its hydrogen and is left sulfur, whereas Cl2 is gaining hydrogen, so it is becoming ACl. So loss of hydrogen is called oxidation, gain in hydrogen is called reduction. Okay, now you can see H2S reduces Cl2 to ACl. That's why H2S is called reducing agent. Whereas Cl2 oxidizes H2S to S. That's why Cl2 is oxidizing agent. So this is an example of gain and loss in hydrogen. Okay, now we are going to read an example of gain and loss of electrons. So look now. Here is an example in which you can see Zn is losing electrons and forms Zn2 plus, whereas Cu2 plus is gaining electrons and forming Cu. So loss of electrons is called oxidation reaction and gain in electrons is called reduction reaction. Okay, now we are giving the details of this. Zn reduces Cu2 plus to Cu. That's why this is called a reducing agent. Whereas Cu2 plus oxidizes Zn to Zn2 plus. That's why this is oxidizing agent. So this is an example of gain and loss of electrons. And finally, we are going to read an example of increase and decrease in oxidation number. So concentrate now. Here you can see Mg is increase in oxidation number, that is from 0. Its oxidation number right now is 0 to +2. So that's why this is called oxidation number. Whereas Fe3 plus is a decrease in oxidation number, that is from +3 to +2. So decrease in oxidation number, so this is called reduction reaction. So here are the details. Mg reduces Fe3 plus to Fe2 plus, that's why it is reducing agent. Whereas Fe3 plus oxidizes Mg to Mg2 plus, that's why this is called oxidizing agent. So these were the examples, students. So first read and understand the concepts of oxidation reaction and reduction reaction, and then these examples that will make your concepts more clear. The next topic that we are going to read in the topic of redox reaction is oxidation number. Oxidation numbers are assigned to atoms according to the following rules. So concentrate yourself. You have to learn and understand these rules, because these rules will be applied in solving the numerical questions. because the numerical questions also come in the paper in which you are required to find the oxidation number of any one of the atoms present in the compound. So concentrate yourself, we are going to start. The first rule is atoms of an element are assigned an oxidation number of 0. So this is the first rule. Second rule, simple monoatomic ions are assigned oxidation numbers that are equal to their charges. So it means whatever the charge of an monoatomic ion is, that will be equal to the oxidation number. Number 3, oxygen atoms in their compounds are assigned an oxidation number of -2. So concentrate yourself. Oxidation number of oxygen is -2, but there is one exception, except in peroxides, where each oxygen atom is assigned an oxidation number of -1. So in peroxides, the oxidation number of oxygen is -1, and except peroxide, in all other compounds, the oxygen will have oxidation number of -2. Next rule is hydrogen atom in their compounds are assigned an oxidation number of +1, except in ionic hydrides, where each hydrogen atom is assigned an oxidation number of -1. So as far as hydrogen is concerned, so oxidation number of hydrogen is +1 in all the compounds, but there is one exception in this also, that is in ionic hydrides. In ionic hydrides, the oxidation number of the hydrogen atom will be -1. Okay, the next rule is group 1 elements have oxidation number of +1. Group 2 elements have oxidation number of +2. And group 3 elements have oxidation number of +3. So this is the rule. Group 1 elements will have oxidation number of +1. Group 2 will have +2, and all the elements in the group 3 will be having oxidation number of +3. The fluorine atom is assigned an oxidation number of -1 in its compounds. Chlorine also has an oxidation number of -1, except when combined with oxygen and fluorine. So this is the rule. Next rule is the sum of the oxidation number of all the atoms must be 0 for an electrically neutral compound. So if a compound is neutral, then the sum of the oxidation number will be equal to 0. So this is the rule. So read again. The sum of the oxidation numbers of all the atoms must be 0 for an electrically neutral compound, and must be equal to the overall charge for an ionic species. So, and must be equal to overall charge for an ionic species. So if the compound is charged, so the sum of the oxidation number will be equal to the charge that a compound will have. Next rule is some elements have a fixed oxidation number in all their compounds. And here are some fixed oxidation numbers. Sodium will have +1, potassium will have +1, magnesium will have +2, calcium will have +2, aluminium will have +3, hydrogen will have +1, halogens will have -1. Halogens are chlorine, fluorine, bromine, iodine, astatine. So halogen group will have oxidation number -1, and oxygen, except in peroxides, will have -2. So these are the fixed oxidation numbers which you have to learn. Okay, next we are going to read is a substance is oxidized when its oxidation number increases. So if the oxidation number increases, the substance will be oxidized, and if the oxidation number decreases, the substance will be reduced. So this is the vice versa process. Oxidation number increases, substance will be oxidized. If oxidation number decreases, substance will be reduced. If the oxidation number of a substance falls, it has acted as an oxidizing agent. So this is important rule, important point. Oxidation number falls, the substance will act as oxidizing agent, and vice versa is there. If oxidation number rises, it will act as a reducing agent. So these are some important points. And now we are going to solve some questions using the rules we have just understand and read. So look now. Example 1 is chlorine Cl2. So the first rule was atoms of an element are assigned oxidation number 0. So look now, oxidation number of Cl is 0. Number 2 is aluminium ion Al3 plus. So look now, the charge is plus 3. So the oxidation number of Al3 plus is plus 3. So this was another rule. Whatever the charge of an atom is, that will be the same as of the oxidation number. So if charge is plus 3, oxidation number will also be plus 3. Next is example 3, carbon dioxide. So if you can see, here is O. So the oxidation number of oxygen in all the compounds is -2 except in peroxides, in which oxidation number of O will be -1. So this is carbon dioxide. So the oxidation number of the O will be -2. Next example is ammonia. Another rule was the oxidation number of H is +1 except in ionic hydrides, in which the oxidation number of the hydrogen will be -1. So in NH3, the oxidation number of H is +1. Next rule was if a compound is neutral, the sum of the oxidation number of all the atoms will be equal to 0. So this was the rule which is going to be applied now. So in this compound, we are going to find the oxidation number of C. So Na is having oxidation number of +1 and O is having oxidation number of -2. So there are 2 atoms of sodium. So that's why 2 into +1. Carbon's oxidation number is in question, so that is put X, and O's oxidation number is -2. So 3 atoms are there, so that's why +3 into -2. The sum of the oxidation numbers must be equal to 0. So that's why we have put equal to 0. Solve it, the simple equation, and X answer will be +4. It means the oxidation number of carbon in this compound is +4. Here is another question which is we will apply the same rule in this compound again. So look now, the compound is electrically neutral. So the sum of the oxidation numbers of all the atoms will be 0. So the oxidation number of K is +1. The oxidation number of oxygen is -2, and we will find the oxidation number of Cr. So look now, there are 2 atoms of K, so that's why 2 into +1. There are 7 atoms of O, so that's why 7 into -2. And there are 2 atoms of Cr, and we have let the oxidation number of Cr is X, so 2 into X. And this must be equal to 0 because this is electrically neutral compound. So that's why we have put equal to 0. So solve this equation, you will get the answer of +6. So it means the oxidation number of the Cr is +6 in this compound. So these kind of the questions come in the paper.